All right, so this one first. This is kind of tedious because each of the equations is written in a different form. So you can't really just find the equation of this graph and figure out which one of these matches it. The best way to go about this, I believe, would be just to find a rough graph of each of these and then just pick which ones you actually see here. So, like this first one, I would graph this one using intercepts. So when x is 0, I get y is 2. And when y is 0, I get x equals negative 2. If I plug in 0, 0, I get 0 is greater than negative 2. 0, 0 works. So I'm looking for the graph that goes through 0, 2, negative 2, 0, and shades towards the origin. 0, 2. None of these go through 0, comma 2. So this isn't any of the answers. This one, same thing. I can use intercepts. When x is 0, I get y is 1. When y is 0, I get x is 1 half. If I plug in 0, 0, I get 0 plus 0 is less than 1. 0, 0 works again. So it has to go through 0, 1. None of these go through 0, 1. So that one's that one. Let's do this until we find the one that actually we do have. This one here goes through 0, 1. This one goes through 1 half. 0. Same thing. This isn't going to pop up because none of them go through 0, 1. Let's look at this one. When x is 0, y is 2. But we already said none of them went through 0, 2. So this isn't any of the answers either. So moving right along, we have when x is 0, y is 1 half. All right, that's different. When y is 0, x is 1. 0, 0 works here. So I'm looking for the graph that goes through 0, 1 half. Well, this one goes through 0, 1 half. And 1, 0. And it's shaded towards the origin. So this is going to be E. That's our E. And then let's see, let's do G then. G, we have a y-intercept of negative 2, slope of 1, origin works. This is going to be G. So you just have to basically graph these 7 or just get a rough estimate where they go through the intercepts. And then you can kind of eliminate the ones you don't want, which means this would probably be F. Okay. This one, it doesn't want all the corners on the graph. It wants just the corners of the feasible region. So notice here, this x plus 2y is greater than 12. That's the green guy. X plus 2y is greater than or equal to 12. And x plus y is greater than or equal to 9. Is that right? Yeah. So if you're going to test the origin into both of them, test the origin here, I get 0 plus 0 is greater than 9. This doesn't work. So with the blue line, I'm shading up, away from the origin. The green line, 0, 0 doesn't work again. So I'm going to shade away. So my feasible region is everything above the blue and above the green. So the only corners they want are the corners of the boundary of that region. So this guy, 0, 9. This guy, 6, 3. And this guy, 12, 0. So they don't want this and they don't want this because this isn't part. These aren't part of the final feasible region. Just those 3 coordinates are.